Okay, time to talk ticks. These little creatures can be smaller than a sesame seed, but they still have the ability to ruin your life. On this Looking at Lyme podcast, we're going to put ticks under the microscope. We're going to examine these tiny little arachnids and get to understand their behavior so that we can learn what makes these blood-sucking arachnids, well, tick. We'll head to a lab with a geneticist who's made a career out of studying ticks and the pathogens that they carry. It's definitely going to be interesting, and it could be a little terrifying because these little creatures are both. Hi there, I'm Sarah Cormode, and I'm the host of the Can Lyme podcast, Looking at Lyme. No one really knows when ticks arrived on this planet, but it was long before we did. At least 90 million years ago, they were here on this planet sucking the blood of dinosaurs, giant rodents, and pterodactyls. They're arachnids. Ticks are more related to spiders than to insects. There's over 800 species of them around the world. They have a complex life cycle that includes larvae, nymph, and adults, and each stage requires a blood meal to survive. Some species of ticks can even go for a whole year without feeding on any blood. Contrary to what you may have heard, ticks do not jump, fly, or drop out of trees. They actually lurk at the end of grasses, leaves, and branches, and they patiently wait for a host to stroll, fly, or slither by. That's when they reach out with their legs and they attach themselves to an unsuspecting host. Mammals, birds, amphibians, even reptiles. Once they attach themselves, they'll feed for hours and more often days. Did I tell you this was going to make you itchy? Okay, we're getting down to the science of ticks and Lyme. And to better understand this, we definitely need to reach out to an expert. Justin Wood is the CEO and founder of Genetics, an Ontario-based company that is dedicated to the research of ticks and the pathogens that they carry. We've reached him in his office. Good morning, Justin, and thanks for joining us today.
No problem, Sarah. My pleasure.
Let's start right at the beginning, Justin. What is a tick?
Yeah, it seems like a good place to start. I think the best way to start with this is that most people think ticks are insects, and ticks are actually arachnids, which makes them more closely related to spiders than to insects. So ticks are small parasitic arachnids. They have 8 legs instead of the 6 that you would see on an insect. And they have to take a blood meal to progress through each stage of their life. So that means they have to find a host, they have to feed on it, and then they can progress through their life cycle. In Canada, we have 2 different types of ticks. We have hard ticks and soft ticks. And what humans are most likely to encounter are hard ticks. These are the kind of ticks you might find out in the environment or on large mammals when you're out hiking or walking through the bush or something like that. So these ticks are really quite small. They're only the adults are about 2.5 millimeters in length when they haven't fed, and the nymphs, which are sort of the juvenile or what you can think of as teenage ticks, they're a lot smaller. They're maybe about 1 millimeter to 2 at max. So they're very difficult to see and spot on you if you're out in the bush.
I remember when I learned that ticks were actually arachnids and have 8 legs for most of their life cycle. And I thought that was really interesting because sometimes people don't really know what kind of insect's on them. But basically, if it has 8 legs, it's more likely to be a tick than an insect.
Absolutely. And I think one sort of issue with that is some insects have very long sensory antennae on the front. So one of the big issues we have is people will submit these beetles that have long sensory antennae, and they think they're an extra pair of legs. And then they think that, this is something with 8 legs instead of 6, and they think it might be a tick, and they send it into us. But in general, ticks will have 8 legs unless they're larvae, which they'll have 6, but the ones that you're most likely to find will have 8 legs.
Now, it seems natural human behavior that if an insect is crawling on us somewhere, we usually swat it. And if we can squish it, it's usually not a tick because they're pretty amazing, versatile creatures who can really live through most things.
Yeah, ticks are hardy. They're quite hard to kill. And we call them hard ticks because they have a hard sort of shield on their back, which protects them from that sort of thing. So they're really quite difficult to squish and kill, you're right.
How prevalent are they across Canada?
Ticks are quite prevalent in Canada, and that really depends on the species for how prevalent they are in different areas. So obviously Canada is a very large country, so we have different types of ticks that you might find more or less in different areas across the country. I think the tick that most people are familiar with is the black-legged tick, and we find that tick from sort of the east coast of Canada and Nova Scotia all the way across through to Manitoba and sometimes even further west than that. On the other side of the country, we have the western black-legged tick, which we find on Vancouver Island and in through interior of BC. There's also the Rocky Mountain wood tick and the American dog tick, which we find sort of all across Canada. The Rocky Mountain wood tick is generally, as you can imagine from the name, something found in the Rocky Mountains on the west coast. And the American dog tick is sort of found again from the east coast across. But these ticks actually overlap in their range in sort of the Saskatchewan area. And we do find Rocky Mountain wood ticks further east, and we do find American dog ticks as far west into BC as well.
And then when a tick does bite you, why don't we feel the tick when it bites us?
Yeah, this is a really interesting question. So tick saliva is actually full of a whole bunch of interesting compounds that help the tick facilitate its blood meal without being detected. So it contains anticoagulants, which means that it can feed on the blood without it getting kind of clogged while it's coming up through that very fine needle that they feed through. They have immune modulators to sort of prevent the host immune system from attacking. And also kind of mixed in there is anesthetics that prevent itching and pain. So generally, when the tick is biting and it's attached, you're not actually feeling anything while it's feeding on you.
And how long do they usually attach to their host, whether it's a human or an animal?
That kind of depends on the tick as well as the life stage that it's in. So for the black-legged ticks and the western black-legged ticks, which I think we most commonly see biting humans, the adults tend to feed for about 6 to 10 days. I would say sort of an average around 7 to 8. And the nymphs and larvae, which again are the younger ticks, they can feed for generally about 4 days. If we're looking at the Rocky Mountain wood tick and the American dog tick, we actually see a much longer feeding period. So the adults can feed for sometime as long as 2 or 3 weeks, depending on the species. And the nymphs and the larvae, they might feed for, let's say, maybe an average of 7 days, but anywhere between sort of 3 to 9 days.
And then as they're feeding, they're getting bigger too, so they're easier to find the longer they're on our bodies.
Absolutely, yeah. When they're feeding, they're starting to engorge, and those ticks that, the adult ticks that might start off at, 2.5 millimeters, they can engorge, maybe up to 5 millimeters. I've seen some even as big as 7 millimeters, so they can really grow quite a bit.
What kind of animals do they attach to?
Again, that's dependent on the type of tick and the life stage it's in. So black-legged ticks and the western black-legged tick, the adults tend to bite medium-sized mammals, up to large-sized mammals, obviously including humans. Whereas the nymphs and larvae, they tend to go for smaller mammals, lizards, birds. These species, the nymphs will also bite humans. Whereas the Rocky Mountain wood tick and the American dog tick, the adults, again, tend to feed on mid to large-sized mammals. But the nymphs and larvae quite rarely bite humans, and they're more focused on small mammals. You might think of mice or squirrels or, things of that size.
It sounds like ticks move around in their life cycle and feed on different hosts. What does their life cycle look like?
Absolutely, yeah. Ticks actually have what's called, or not all ticks, but the ticks that we've been talking about here have what's called a 3-host life cycle. So that means each life stage they will find a new and different host to feed on. Then they'll drop off that host and they'll progress through the next stage of their life cycle. So with these types of ticks, the life cycles usually take about 3 to 4 years, depending on how quickly they find host and what period of the year they find that host in. So sort of starting from the beginning, I think the most logical place to start is probably with larvae hatching from eggs. So, an adult female tick might lay hundreds to thousands of eggs depending on the species. These will hatch into larvae, and the larvae will come out. And the larvae are not very mobile, so they'll sort of be in one area. And then maybe a small mammal or something will come through. They'll walk through that sort of tick nest, and they'll pick up a bunch of these larvae. The larvae will then feed for a couple days, and once they've reached something called repletion, which is when a tick is completely full, it's got enough of a blood meal to go to the next stage, they'll drop off of that mammal, they'll find a place that they're kind of safe in, and they'll molt into the next stage, which is a nymph. The nymphs will then start to seek hosts, and they'll do this by climbing up some vegetation and trying to find a passing, small mammal or bird or something like that to feed on. If something comes close enough and they contact it, they'll again take that blood meal. Again, probably about 4 days for these. They'll drop off, they'll molt into adults, and then the process will repeat. So the adults will come out and they'll try to find a blood meal as well. So they'll begin host seeking, climb up the vegetation, search for a suitable host, attach to it, take that large blood meal. This is where things start to get a little different, because for the first time in adults we have both male and female ticks. So females are actually the ticks that will take that really large sustained blood meal while they're attached for about 6 to 10 days and feed, whereas the males will take a much shorter blood meal. It's just long enough for them to prime themselves to mate with the females. They'll mate generally on the host and then drop off. The female will find a safe place to lay her eggs, and she'll lay again hundreds to thousands of eggs. She'll die, and the whole process will repeat again.
How can a tick bite affect human health?
Yeah, this really depends, on the tick that's bitten you and sort of the process that happens. So, as you probably know, some ticks carry pathogens, which are agents that can cause diseases. So, in the event that a tick bites somebody and it happens to be carrying some pathogens, there is a process that can happen where those pathogens can then be passed from the tick, where they're usually stored in the gut or the salivary gland, into the human, and that can lead to an infection and lead to disease. So if that happens, we can actually have really severe impacts on human health from tick bites. In other cases, the tick may not be carrying any pathogens and it won't transmit anything, or it might be carrying pathogens and there's just no transmission that occurs between the tick and the human. Outside of passing pathogens on to human, there's other ticks that cause diseases just by their bite, or I shouldn't say diseases, they cause illnesses through their bite. So one example of this is a Lonestar tick, which is a tick we don't see particularly frequently here in Canada, but we have seen reports of it being carried up here by migratory birds or migrating animals. And this tick actually has a component in its saliva that causes a severe red meat allergy when it bites. This is called alpha-gal syndrome. And people that are affected by these Lonestar tick bites then can't eat red meat, as they have a very severe, sometimes anaphylactic reaction just to eating that meat.
Are you seeing other kinds of pathogens as well in the ticks that are being submitted to your lab for testing?
Yeah, we're seeing quite a few pathogens in the ticks that are submitted to us. By far the most abundant is the Borrelia species of pathogens. So these are the bacteria that are responsible for causing Lyme disease. Borrelia burgdorferi, which is the main strain that causes Lyme disease, main species that causes Lyme disease here in Canada, we're seeing quite abundantly in black-legged ticks that are submitted to us. We're seeing those in about, I'd say, 17-18% of ticks that are submitted across Canada. And if we focus on just our submissions from Ontario, we actually see that number rise to about close to 20%. Outside of Borrelia species, we're also seeing things like Anaplasma phagocytophilum, which causes human granulocytic anaplasmosis. We're seeing Babesia species, which cause babesiosis. We're seeing Borrelia miyamotoi, which causes a relapsing fever illness. And outside of what we've just detected through our particular research, if you read through the literature, we're also finding other species of pathogens in Canadian ticks, such as something called the Powassan virus, which can cause a quite severe illness called Powassan encephalitis. We're seeing the Rocky Mountain spotted fever pathogen, Rickettsia rickettsii. We're seeing tularemia. Some Ehrlichia species are starting to show up. These are not all just in black-legged ticks. Some of these are actually more common in the American dog tick or the Rocky Mountain wood tick or even the Lonestar tick when we do see it here in Canada.
Do you think global warming's playing a role in the ticks spreading throughout Canada?
Absolutely, yeah. This is a really important point that you're bringing up. So global warming is very much, or climate change is very much playing a role in the expanding tick populations in Canada. So what we're actually seeing is that the winters tend to be shorter and less intense as time passes here. And what this means is we're actually having longer seasonal activity for ticks. So we kind of talked about the life cycle there before, and I was telling you about how ticks have to find a host, feed on that host in order to progress to the next stage of their life. So previously, when we had longer winters, there was a shorter period of time for ticks to find those hosts and progress through their life cycle. So as these seasons get longer, we're seeing a larger percentage of ticks are finding meals. That means more ticks are molting at each life stage and, going from larvae to nymphs and nymphs to adults. And it means that more adults are finding meals and allowing them to lay eggs. So this means there's an increase in tick abundance pretty much every year, which, as you can imagine, is quite frightening. And on top of that, we're actually seeing that these sort of warmer temperatures are allowing the reservoir species. So these are the small mammals that are the reservoirs where these diseases sort of live, are moving. Their ranges are expanding in Canada. And that means that the more the more ticks that we're seeing have a higher chance of carrying the sorts of diseases that we're concerned about because they're able to feed on these infected reservoir species. And sort of to cap all this off, and as if it's not frightening enough, as the climate changes, it's becoming more suitable for other species of ticks and other pathogens to establish. So we're seeing the range of some ticks that we normally see only in the south, let's say in the United States, are actually being able to move up and establish closer to our area and into our area. So it's really causing, quite a few concerning issues.
Do we know what the current range is for ticks that are carrying Lyme disease and other co-infections?
The range, I think the range probably kind of matches with the distribution of the ticks quite closely, and then sort of where the reservoir species are present. So trying to map the range is a little bit more of a complicated issue than you might think. And so when we look at our submissions based off of, looking at all of Canada overall, like I said, we might see, 17% of ticks carrying Borrelia. We look just at Ontario, we might see more like 20%. So we have certain areas that have higher percentages of ticks carrying these species. These are called endemic areas. And even within a single province, so again, looking at Ontario, which we're focused on, we might see one part of Ontario that has quite a low percentage of ticks carrying Lyme disease, and we'll find another area that's called hyperendemic, and they have a much higher percent. So within Ontario, I'd actually say there's probably a range of places where there's about, a very, very low percent chance of finding a tick carrying Borrelia. And then there's places where you might see ticks carrying, as high as 40 to 50% of ticks carrying the pathogen that causes Lyme disease.
What fascinates you most about your tick research?
I think what I generally find most fascinating about tick research is, finding things that we didn't expect to find. So obviously we get submissions from all over the country, and this has led to certain species of ticks being submitted from places where you don't really expect to find that type of tick. And that's always interesting because different ticks are associated with different diseases. And it kind of tells you, okay, we didn't expect to see this tick here. It's not been, it's not been published as being present in this area, and we've had a submission here. So what does that mean for the potential for the diseases to be in that area as well? And another thing that I found quite interesting is sometimes we're looking at ticks for species that haven't really been, searched for in that species. So we might find a certain species of tick is carrying a disease that we didn't expect it to find. And I think those two things are really important because there's still a lot of, mystery surrounding tick-borne diseases in Canada, where they are, what's carrying them, how they're being transmitted. And anything that we can find that's new in that helps us, shed a little bit of extra light on how this disease is progressing in Canada.
That is so fascinating, Justin. Thank you so much for sharing your time and your expertise. I really find it interesting to hear how you are seeing in real time where ticks are in Canada. And then when you get to take them apart in the lab, you get to see what kind of pathogens they're carrying. I think it's really important
Absolutely.
that we're collecting that information.
My pleasure. Thank you, Sarah.
Wow, that was fascinating. I learned so much. I'm glad that someone's collecting real-time data in Canada about where we're finding ticks and also what kind of pathogens they're carrying. We'll check in with Justin again in the future when we have more specific questions around testing for ticks. I'll see you on the next podcast, and in the meantime, stay safe in the outdoors.